A giant comet has been found in our outer solar system. It's been found by the Dark Energy Survey. A giant comet from the outskirts of our solar system, discovered in 6 years of data from the Dark Energy Survey. The comet is named Bernardinelli-Bernstein. It's estimated to be about 1,000 times more massive than a typical comet, 1,000 times bigger, making it arguably the largest comet discovered in our modern times. It has an extremely elongated orbit, journeying inward from the Oort cloud over millions of years. It's the most distant comet to be discovered on its incoming path, giving us years to watch it evolve as it approaches our sun, though it's not predicted to become a naked eye spectacle. The giant comet has been discovered by 2 astronomers following a comprehensive search of data from Dark Energy Survey DES. The comet, which is estimated to be 100 to 200 kilometers across, that's pretty big, or about 10 times the diameter of most comets, is an icy relic flying out of the solar system by the migrating giant planets in the nearby history of the solar system. This comet is quite unlike any other seen before, and the huge size estimate is based on how much sunlight it reflects. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Pedro Bernardinelli and Gary Bernstein of the University of Pennsylvania found the comet, named after them of course, Comet Bernardinelli-Bernstein, hidden among data collected by the 570 megapixel dark energy camera DECAM, mounted on the Victor M. Blanco 4-meter telescope at Cerro Tololo Inter-American Observatory in Chile, STIO in Chile. The analysis of data from the Dark Energy Survey is supported by the Department of Energy DOE and the National Science Foundation NSF, and the DECAM Science Archive is curated by the Community Science and Data Center at NSF's Noir Lab, CTIO, and CSDC programs. One of the highest performance wide field CCD imagers in the world, DECAM was designed specifically for DES and operated by DOE and NSF between 2013 and 19. DECAM was funded by DOE and was built and tested at DOE's Fermilab, and right now the DECAM is used for programs covering a huge range of science. DES was tasked with mapping 300 million galaxies across 5,000 square degree area of the night sky, but during its 6 years of observations it also observed many comets and trans-Neptunian objects passing through the surveyed field. A trans-Neptunian object, or TNO, is an icy body that resides in our outer solar system beyond the orbit of Neptune. Bernardinelli and Bernstein used 15 to 20 million CPU hours at the National Center for Supercomputing Applications and Fermilab, employing sophisticated identification tracking algorithms to identify over 800 individual TNOs from among the more than 16 billion individual sources detected in 80,000 exposures taken as part of DES. 32 of those detections belong to one object, that is, theirs. Comets, as we know, are icy bodies that evaporate as they approach the warmth of our sun, growing their coma and tails. The DES images of this object did not show a typical comet tail, but within a day of the announcement of its discovery via Minor Planet Center, astronomers using the Las Cumbres Observatory Network took fresh images of Comet Bernardinelli-Bernstein, which revealed that it has grown a coma in the past 3 years, making it officially a comet. Its current inward journey began at a distance of over 40,000 astronomical units from the Sun, in other words, 40,000 times farther from the Sun than Earth is, or 6 trillion kilometers away. And for that's about 0.6 light years. That's a seventh of the distance to the nearest star. For comparison, Pluto is 39 AU from the Sun on average. This means that comet Bernardinelli-Bernstein originated in the Oort cloud of objects ejected during early history of the solar system. It could be the largest member of the Oort cloud ever detected, and is the first comet on an incoming path to be detected so far away. Now, the comet Bernardinelli-Bernstein, currently much closer to the Sun, first seen by DES in 2014 at a distance of 29 AU. It was, as of June 2021, it was 20 AU, or 1.8 billion miles, the distance of Uranus from the Sun. 3 billion kilometers, or 1.8 billion miles, is the distance of Uranus from our Sun, and currently shines at magnitude 20. The comet's orbit is perpendicular to the plane of the solar system, and it will reach its closest point to the Sun, known as perihelion, in about 10 years, in 2031, when it will be around 11 AU away, a bit more than Saturn's distance from the Sun. But it will get no closer, they said. Despite the comet's size, it's currently predicted that sky watchers will require a large amateur telescope to see it, even at its brightest. Now, Gary Bernstein said, "We have the privilege of having discovered perhaps the largest comet ever seen, or at least larger than any well-studied one, and caught it early enough for people to watch it evolve as it approaches and warms up. It has not visited the solar system in more than 3 million years," he said. It will be followed intensively by astronomical community, including with Noir Lab facilities, to understand the composition and origin of this massive relic from the birth of our own planet. Astronomers suspect that there may be more undiscovered comets of this size waiting in the Oort cloud far beyond Pluto in the Kuiper Belt, and these giant comets are thought to have been scattered to the far reaches of the solar system by the migration of Jupiter, Saturn, and Uranus and Neptune early in their history. This is a much-needed anchor on the unknown population of large objects in the Oort cloud and their connection with early migration of the ice gas giants soon after the solar system was formed. Todd Lauer of Noir Lab astronomers said, "These observations demonstrate the value of long-duration survey observations on national facilities like the Blanco telescope. Finding such huge objects like Comet Bernardinelli-Bernstein is critical to our understanding of the early history of our solar system." This was reported to Minor Planet Center, and it's from the National Science Foundation on phys.org. Please leave your comments, and thank you for your support.